Hi class, in this lecture we will be talking about the measures of dispersion. The measures of dispersion we will be looking at include the range, the mean deviation, semi-interquartile range, 10 to 90 percentile range, variance, standard deviation, and the coefficients of variation. It's important first that we define the measures of dispersion, and for the purpose of this study, for the purpose of this class, we will describe them as those measures that indicate spread or show how diverse the scores in a given data set are. And the first one we will be looking at is the range. The range is simply the difference between the highest value in a given distribution and the lowest value in that same distribution. And so the formula for range is maximum x minus the minimum x. And if we look at the distribution we have here, we will see that okay, so this observations 4, 5, 6, 4, 3, 9, 15, 12, 10, and 4. We will see that the maximum distribution in this case is 15 because it's the highest observation there, and the minimum there is 3. So our range will be 15 minus 3. So we will say that the range is 12. Another measure of dispersion is the mean deviation, which is also known as the average deviation or the mean absolute deviation. And we will come to understand why we refer to this as absolute deviation, the average absolute deviation. But it's important that we point out that the mean deviation is the average difference between the mean and all other values in a given distribution. That is, this measure shows on the average how the different values differ from the mean. Here is the here we have the formula for the mean deviation if we're talking about ungrouped data, and beneath that we have the formula for the mean deviation if we're handling a grouped data set. Okay, so to compute the mean deviation of these values 4, 3, 4, 2, 5, 6, 5, and then 3, all we need to do is first find the mean. We will remember that the formula for mean is summation of f x over the summation f, or put simply, we will just need to add up all these numbers and then divide that by the total number of observations. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8 observations. So if we add all these up and divide by 8, we will have our mean. And so that's how we got this figure here. We added these ones up and then divided by 8. That gave us a mean of 4.875. Remember, we were talking about the difference between the values and the mean. And so we will need somewhere to compute x minus x bar. That is each observation minus the mean, and that's what we have in this column here. So after doing that, we will now need to find the absolute variations. By absolute, it means that we're talking about the absolute difference taking away the negative signs. So if we say here we have 4 minus 4.875, that gives us negative 0.875. But in absolute terms, the difference is actually 0.875. And so for this column here, we're dealing with absolute differences, which means that all the negative signs will go, and then we will be left with positive signs with positive numbers only. And so if we add up that gives us 13.75. Remember, the formula is summation of absolute x minus x bar divided by n. In this case, if we add up all of these, we have 13.25, and then we'll divide by 8, which is our n, and that gives us this 1.656. So that's how we find the mean deviation when we're dealing with ungrouped data. Now, let us assume that we have a data set that is grouped like we have here. We have class intervals here, 118 to 126, 127 to 135, and so on. And these are the frequencies. So to find the mean deviation for this data set, the first thing we want to do is to find the class mark for each class interval. And to do that, all you need to do is add the lower class boundary to the upper class boundary, in this case 118 plus 126, and then divide that by 2. That will give us the x, that is the class mark. And so here we have a column. We'll do that for all the classes, and then you have your x column computed. But we also need, because the formula says summation of f times x minus x bar absolute, and so we will need to calculate first our x bar, which is the mean. We remember the formula for x bar is summation of fx divided by summation f, and so we need this column for summation fx. And so to do fx simply means f times x. So here we will say 3 times 122, that gives us 366. 5 times 131 gives us 655. We will do that for the entire column, and then we will have fx. If we add up this column and divide that by 40, that gives us 146.975, which is our mean. And so we will put that value in a column. Remember, we need x minus x bar. And so in this case, for the first class, we will say 122 minus 146.975, that gives us minus 24.975. For the second class, we will say 131 minus 146.975, that gives us minus 15.975, and we will continue until we're able to compute the whole of that column, that is the column for x minus x bar. When that is done, we will need the column for absolute scores. To get your absolute scores, you're dealing with the same numbers that you have in this column. The only difference is that your negative signs will be taken away, and so you'll discover that here, rather than put minus 24.975, we have 24.975. Here we're changing 15.975 to, we're changing minus 15.975 to 15.975, and so we will do that to compute the x minus x bar column. When that is done, we will now need to multiply the frequency by the absolute differences that we have, and so that's how we will compute the last column here. And to do that, we will say f, that is the frequency for that class. In this case, the frequency is 3. We will multiply that by this 24.975, and that gives us 74.925. We will do the same thing for the second column. 5 times 15.975, that gives us 79.875. So we will do that for all the classes, and at the end we will sum up all the figures in this column. That gives us 435.15. So to calculate the mean deviation, we will divide 435.15 by 40, which is n, and then the mean deviation is obtained by doing that. That gives us 10.87875. The next measure of dispersion that we will be talking about is the semi-interquartile range. We could talk about the interquartile range itself, or the semi, that is half of the interquartile range. And this is the difference between the upper quartile and the lower quartile. If we talk about quartile, we talk about a fourth. So if you divide a distribution into 4 equal parts, we will say that you have divided the distribution of the data set into 4 quartiles, which means that each quartile is 25% of the entire distribution. And if you look at the figure here, the middle here marks the median, that is the point that divides the distribution into 2 equal halves. So the median divides a distribution into 2 halves, while the quartile points divide them into 4 equal parts. The implication is that each part is 25%. So if we're talking about the semi-interquartile range, we are talking about first, if we're talking about the interquartile range, we are talking about the gap between this point and this point. That is the interquartile range. So it is the range of the middle 50% of the cases in a distribution. This part accounts, this part from this point to this point, that accounts for the middle 50%. This part accounts for 25%, but the upper 25%, while this part accounts for the lower 25% in the distribution. And if we look at this data set, we have 2, 2, 3, 3, 4, 4, 5, 6, 6, 6, 7, 8, and 14. First, if we ask you to find the median here, the median is the middlemost number, which means that you want to find a point that divides the distribution into 2 equal halves. If we count here, 1 here, 1, 2 here, and we count 2 here, 3, 3, 4, 4, 5, 5, 6, 6. This is the middle point, so that is naturally the median. Okay, so for this now, if we're talking about the interquartile range, it means that we are looking at Q3, that is the third quartile point, minus Q1, which is the first quartile point. So to find that, if in this case now my Q3 is somewhere between 6, that is the midpoint between this value and this value, is my Q3. And so to find that, I will simply say 6 plus 7 that gives me 13. I'll divide that by 2, that gives me 6.5. And then the Q1 is somewhere between 3 and 3, so the value there will be 3. It means that my Q1 value is 3 and my Q3 value is 6.5. So to find the interquartile range, I will subtract 3, which is Q1, from 6.5, and that gives me 3.5. If the question is to find the semi-interquartile range, that is half of the interquartile range, then all I need to do is divide 3.5 by 2, and that gives me 1.75. When dealing with